Hello friend, welcome to my YouTube channel Electrical Boost. Today we are going to discuss what is semiconductor device, and after that we are going to one component of the semiconductor device. In our previous chapter we learned about the what is the passive component. What is the passive component, like that resistor, inductor and capacitor. Today basically go for the start with the same diode. Before diode we start with what is the semiconductor device. It is an electronic component, or you can material, a component made from a material with conductivity between the conductor and insulator. This they're telling like that semiconductor device is made of from one material. That material conductivity lies between conductor and insulator. You already know about what the conductor resistance is less and the insulator resistance is too high. In the semiconductor, that is conductivity between, now it is a now this is a conductor now nor a insulator. Basically main we are using the silicon and the germanium, the most common semiconductor material. But in the practical case we directly not use the pure semiconductor. The process we are going to tell how. This device, in the semiconductor device, can individual component like that diode, diode, transistor, and MOSFET. This is the individual components that made from the semiconductor material, and we can using this semiconductor device number of part of complex integrated circuits, mainly IC also formed with this material by combination of those transistors and diodes. Okay, this is most basic component or major component or a device or material you can use as in this by using this semiconductor device. Basically what is the function of this device? We can make a switching circuit, and amplifier circuit. Switching circuit you can tell by using the diode and a transistor. Amplifier also you can use by op-amp, also the one of semiconductor device. Due to this variable conductivity property, it can, how will make this variable property by adding, suppose this is a semiconductor device, by adding some impurity we make somehow more conductivity and also less conductivity. This process is called doping. The adding impurity to a pure semiconductor is called doping. It is called doping. In the case of diode, we can control the direction of the current. In case of transistor, you can say we can control the current by adding the impurity or showing the path of this one. By adding impurity in the semiconductor device, suppose if you add more positive in a semiconductor, in a more positive impurity or holes in a semiconductor material, that is called P type. This is called P type semiconductor material. If suppose I add in a, this is a semiconductor material or silicon or germanium, if I add more negative or electrons This is called N type. This is called N type semiconductor. N type semiconductor. By using those two, P and N type, we go make different circuit. First, today video we are going to discuss what is diode and what is the work of diode. In the later video we are going to discuss other components like the transistor and MOSFET and their uses also. For now we start with diode. Diode basically consists of two PN junction diode. Well, it's one PN junction means if you add one P to N, this form as diode. What happen in diode? Suppose this is one P. P means here more positive or holes. Here less amount of holes, more amount of electron, negative charge. What they form? Suppose normally if you make a junction, then it will form a depletion layer. Then it form depletion layer, means the positive charge is goes to attract by negative, and so that, and here negative, means it will make a depletion layer. For that reason it will block the flow of complete, because they are not potential to move this completely. Suppose I connect or give an external supply. Suppose I going to connect one positive terminal to the P and negative to the N side. What happen? Here more positive will come. Means more charge will come. Here more negative. So that what happen? The current can easily flow P to N, because this is the positive that will attract a negative, so that the electrons flow like this and current will flow like this. This condition is called forward bias. This condition is called, what is the forward bias? Forward bias means if the positive is connected to P and negative to inside of the diode, then it is called forward bias. If that it is reverse, that if this is reverse, suppose see here I make reverse bias condition, means if suppose I make here P, here the N, and I connect P to negative, okay, and N to positive, that time what happen? This is the positive, then whatever the electron it will go like this. What the positive go like this, then this depletion layer is length is increase or width is increase, so that the current will not allow to flow in reverse bias condition. Basically in the practical field, diodes are so many types. You can see here on the screen, it look like different configuration, like according to the current rating and other thing. Okay, basically the symbols of diode is like this. You can represent, this is the anode and this is the cathode. Due to how much voltage we apply, it will break down and it allow to flow the current. That condition is called, we can check by VI. This is the VI curve. Here you can see this region is called the forward bias. What happen in the forward bias? At some voltage, in case of silicon, this is 0.7 volt breakdown voltage. In case of germanium, this is 0.3 volt. What happen? When this forward voltage is increased more than the 0.7, that time it allow to current flow. This is called forward VI curve. When you see, when voltage increase 0.7, that time after that current will increase. This is called in the reverse bias condition. What happen? In the reverse, at so many voltage, This is called reverse breakdown voltage. After that it can connect, but it will be damaged. Okay, it will be damaged. While you buying the diode or for using the practical, we can see the in the data sheet, you can see how the breakdown voltage, what is the reverse breakdown voltage, what is the current, according to this we can use for our circuit. Where the practical use of this diode we can use as rectifier. In the rectifier circuit we are using the diode for making the AC to DC. Here you can see the here how the directional control. So in positive direction it will allow the current flow. In the negative direction it cannot allow, so that in the negative it will block, in positive it allow. So for this feature we going to use making the AC to DC. Next it can have reverse voltage protection, reverse voltage protection circuit, reverse voltage or reverse polarity protection. Suppose you can see some charging circuit, when we apply, maybe sometime from battery also it can back to the circuit. So that reason we are connected like this diode. Suppose this is the charging circuit, this is the battery, and this is the charging circuit. When the charge itself it going like this, but when the battery try to back the energy, that it is reverse bias condition, so that it will block, it will protect our charging circuit. Okay, and so many other things also, the practical example there. In later video we are going to discuss, and also we try to make one video and practical also diode. I can show here how this curve will changes. Okay, thank you. I hope you enjoy this video. Please like and subscribe if you enjoy this video. Thank you again.